Hi there, are you guys ready for the next episode? Sure you are. The next episode of Math Magic will make you understand the concept first before getting into the problem. It's very important as you set back to school this January. Are you guys ready? Ladies and gentlemen, welcome to the second to the last episode of Math Magic for this year 2020, Deriving Equations and Formulas. Hey guys, this is Enrique from Math Magic. Have you ever been stuck in the middle of an exam trying to think which formula to use? Have you forgot all those modular formulas you have memorized last time? What have you been doing in those formulas? Did you just memorize all those modular formulas without getting to understand the concept? That is probably the common mistake of many students, as they try only to memorize those formulas even without understanding what are those elements of the formulas. Why are they there? Why is it present? What's the reason why are they there? How do we get it if one of them is missing aside from the main formula itself? Those are actually the common questions in order for you to get that formula. So, this lesson, Math Magic, will make you understand how to derive certain formulas, how to derive certain equations, and especially we're going to understand differences between equations, formulas, expressions, and many more. You do not have to memorize those modular formulas in order for you to get the 100% accuracy in the exam. All you have to do is just to get the main formula and then understand its elements, and then right after that you have to try whether if each of them is missing aside from the main formula itself. For example, if we have a formula in physics, for example, force is equal to mass times acceleration. So whenever we have that formula, what if mass is missing? What if acceleration is missing? What do we have to do? So that thing that you would start to do whenever you would try making mass would be your main formula itself. That's actually called derivation or deriving. That you're actually deriving the formula. So when you want to make mass the missing, and you want to make a formula for mass, which is actually coming from an equation of your basis, like force is equal to mass times acceleration, then you are deriving the formula. Making us understand the concept of an equation or formula will make us have a bigger chance of getting a perfect score in an exam. And aside from your prediction that these formulas are just only for problem solving, actually there are also other cases wherein the formula is also going to be tested in true or false. So you would essentially have to understand that formula before getting into the problem solving itself. Now, getting ready to understand how to derive an equation or formula, we have to first understand their differences. So the first one, we have an equation. An equation is a more mathematical term because it actually has an equal sign. So when we talk about mathematically, we always talk of that equal sign in the middle, and then we have two signs. We have the left side and the right side. That right side of the equation can have different terms, can either be 1 or 2 or more. And they are actually separated by a plus sign, minus sign, multiplication sign, or a division sign. Same with the left side of the equation. They can either be also having 1, 2, or more terms, and they can also be separated with different operations. So a formula, on the other hand, is an equation that does this. This is the way in order for us to get a certain value. Formulas, unlike equations, cannot have more than one term in one side of an equal sign. That's because it tells us how to get the certain value. We cannot say that the formula is more scientific because we also use formulas in mathematics. Specifically, we have the midpoint formula, quadratic formula, and more. The extra one is an expression. An expression is a mathematical statement that lacks an equal sign. And equations that do not have an equal sign, but instead they do have not equal sign, they have a greater than sign, a less than sign, greater than or equal to sign, or less than or equal to sign. They are not then called equations, but they are rather called inequalities. However, having an estimation sign in the middle makes them say that they are actually equal, however they only are different in as they are approximate values. So, for example, we have here 12, and then that estimation sign 12.07. So that would actually be considered equal at that point. However, they're just only different in their decimal point. Alright, now you understand the differences between equations and formula. Now let us move on with understanding the parts of an equation or formula. So consider this one. We have here a is equal to b plus c. An equation always has an equal sign on the middle of two expressions. Okay? These two expressions are actually mathematical statements. Okay, they are actually They are now connected with an equal sign, making them an equation. So both sides can either have 1 or 2 or more terms, and they can be all separated by different or same operations. The equation practices the property of equality, just because of that presence of the equal sign. Now, the property of equality states that Whatever you do on both sides of the equation, whatever you do on this side of the equation must also be done on the right side of the equation. To understand it further, let's move on to the basics of deriving an equation. In A is equal to B plus C, this simply looks like a formula. Yes, it is, because it tells us how to get A. That is of current. What if B or C is missing? Let us transform the formula to the problem. For example, we have here 14 is equal to B plus 7. So what do we do when letter B is missing? We have letter A, that's equal to 14. Now, we have letter B as our problem now. We need to find the value of B. Although we can predict that the value of B is equal to 7, we need to find out how did we get it. So, in order for us to get B, we are going to put 7 to the other side of the equation. We simply put 7 to the other side with an opposite sign, calling it a transpose procedure. However, we cannot get to understand why do we have to put an opposite sign. The full process is eliminating the 7 in that side of the equation using a different sign, that is negative. We should also do the same thing on the other side, where we can insert negative 7. That is the point of the property of equality. Both sides receive the same treatments. Whatever we do to the right side must also be done to the left side. So we have already moved negative 7 to the left side of the equation. So this makes our equation turn into negative 7 plus 14 equals B. Now it's clear. We can just only solve 14 minus 7, or negative 7 plus 14. And our answer would be 7. 7 equals B. Whether that B is on that position or in the opposite, same answers would be generated. So 7 is equal to B and B is equal to 7. You may be asking, isn't it that once we put B on the other side, it would be negative? Yes. However, we're finding the answer for B, positive B. So this time, we are going to remove that negative sign on those terms. So what are we going to do is that we are going to divide negative 1 on both sides. That's because we want to remove that negative sign, making it just be equal to positive B. We are then going to get an answer of B equals 7, which is the same thing like how we did it a while ago. If C is missing, we will also follow the same procedure. C will be the one that's going to be left on the right side of the equation, and letter B, which is actually 7, has to be moved to the other side of the equation. If we still have the same example, 14 is equal to 7 plus C, we're going to have negative 7 plus 14 is equal to C, making us get an answer of 7 equals C, and reversing it, we'll also be getting the same answer. Always remember to leave the missing value right where it is. So the ones with value will be moved to the other side. Next, we have here A is equal to B minus C. So this time, the terms are separated by a minus sign. So how do we do that? The procedure varies depending which is missing. If B is missing, then we have to use a positive sign. But if C is missing, we have to use a negative sign so that we can move that to the opposite side. Alright, so that is when B is missing. Alright, next we're going to proceed with multiplication and division. Alright, so first we're going to have multiplication. Once A is equal to BC, this actually means that they are together with an invisible multiplication sign. That means you cannot just separate them by using plus or minus signs. They are connected. So what are we going to do is that we are going to divide them. Okay, whether B or C is missing, we're going to divide them. When B is missing, we're going to eliminate C. When C is missing, we're going to eliminate B. In division, same procedures will be followed whether B or C is missing. If B is missing, then we have to eliminate C. If C is missing, then we also have to eliminate C. So, let's say for example, 5 is equal to 15 over C. So this time C is missing. So we have to eliminate that C. So this means that we're just going to eliminate the denominator only. So following the procedure, we have to create a fraction right beside 15 over C. So that fraction must also be accompanied with a multiplication sign. So we're going to put the thing that we want to eliminate, that is the denominator, right on top of that new fraction that we're creating. So we're going to have C, and the denominator of it would be 1. So C over 1. So we're going to have 5 is equal to 15 over C multiplied by C over 1. Alright, there. So we're going to cancel C and C. And then we're going to be left with 15 over 1, but that will just be equal to 15. And then right on the other side of the equation, we're also going to do the same procedure. We're going to multiply 5 by c over 1, but just leaving us with an answer of 5c. Alright, now that we have 5c, and then we have 15 on the other side of the equation, we're just going to divide both sides by 5. Why do we have to divide both sides by 5? In order for us to get c. We're going to eliminate 5 from c in order for us to get the value of c. So, dividing both sides by 5, we're going to get an answer of 3. So, if b is missing, like for example, 5 is equal to b over 3, the same procedures will have to be followed. All we have to do is just to eliminate the denominator using a fraction. So, we have here 5 is equal to b over 3 multiplied to 3 over 1. So then we can eliminate 3, and then doing the same procedure on the other side of the equation, so we have here 3 over 1 times 5. So 5 times 3 is equal to 15. Our value then for b is equal to 15. Next one, we have double operations. So what are double operations? So for the word double, that means that they have 2 or more elements separated by 2 different operations. So here we have it in the board. You would see that there are different equations here. So if you would actually recognize that they are like the framework of a certain equation or formula, that's correct. What I'm trying to teach you here is that you guys are going to face several formulas that look like this one's on the board. Like for example, for the formula of final velocity, we have this one. So so this one is final velocity. So you have your final velocity is equal to initial velocity plus acceleration multiplied by time. Right, there we go. So what if acceleration is missing? Or what if time is missing? What if the initial velocity is missing? So we have to understand how to derive this equation whenever each of these are missing. So we cannot actually just memorize a formula for acceleration, which is already in our heads right now. Acceleration is equal to final velocity minus initial velocity all over time. How do we get that anyway? Probably because of the formula for final velocity. And we can also derive that vice versa. By the formula of acceleration, we're going to get the final velocity. It's just only a repeated cycle. Alright, so there are also formulas that have this type. There are formulas that have this type and the ones right here. So how to derive certain equations or formulas like these? Next, we're going to find out in the next episode of Math Magic. See you guys again in another episode. This is Eric. Stay safe and keep following Math Magic.